So in a geometric sequence, the ratio of any term to the previous term is constant. So we call the common ratio R. So in 12.2, when we had arithmetic sequences, they were all added by a constant or subtracted. So it was add and subtract. In 12.3, when we have a geometric, they're all multiplied or divided by some sort of constant. So the only difference is that arithmetic is add and subtract, geometric is multiply, divide. So in number 1, for A, B, and C, we're going to take the second term and divide it by the first term, so the previous one. And if they all have the same ratio, then that would mean that it is geometric. So if we look at A, I'm going to take the second term, which is 10, and I'm going to divide it by 4. And you could use your calculator, but it is 2.5. You could reduce it and do 5 over 2. That's also fine. Actually, I do prefer fractions. And then I'm going to take 18 over 10. 18 over 10, and that would be 9 fifths. Which would reduce to 1, if it's a decimal, 1.8, but they're not the same. So then I would say no. So then for B, I'm going to take 125 and divide by 625. So I'm taking the second term and I'm dividing it by the previous. So I have to multiply 625 by 1/5 to get 125. Exactly. So then I'm going to take 25, divide by 125, and that reduces to 1/5 as well. 5 over 25 is 1/5. 1 over 5 is 1/5. So I would say yes. So then for part C, 2 over 1 is just 2. 6 over 2 is 3, so no. This formula will always be given to you. So we had a rule for the arithmetic one. That was where you have a sub 1 plus n minus 1 times d. This is the formula for geometric, where you have a sub 1, which is your first term, and then you put the ratio in parentheses and you raise it to the n minus 1. So the only thing that you'll be filling in for a generic formula will be the first term and then r. You leave these a-n and then n minus 1. You leave those with n's in them, unless it wants you to find a specific number. So if I look at A for number 2, I'm going to fill in what I know. So if I write the generic formula, a sub n equals a1 times r to the n minus 1. I need my first term, which is 4, and then I also need my ratio. So to find my ratio, I'm going to take my second term and divide it by the first term. So r equals 20 divided by 4, which is 5. So my generic formula would be a(n) equals a1, which is 4, parenthesis, 5 to the n minus 1. Then it wants me to find, so in the problem, it says, then find a of 7. So a of 7 equals 4 times 5 to the 7 minus 1, which is the 6th power. So then you'll just type that into your calculator, and you end up getting 62,500. Okay, so my first term is 152. So that's my A1. And then to get my R, I'm going to take negative 76 over 152. And what did you get? What did that reduce to? Negative 1/2. So I have my R and I have my A1, so I'm going to plug that in. My generic formula would be AN equals A1, which is 152, times negative 1/2 to the n minus 1. And if I want to find what A7 is, I'm going to plug 7 in for n. So So 152 negative 1/2 to the 7 minus 1, or to the 6th power. So what did you get when you typed that in as a fraction? 19/8. Good. And then if you got it as a decimal, it would be like 2.2, 2.3, 2.4, something like that. You can do it as a decimal. Okay, so then for part C, it's kind of like it's the same process. So what if you're just given a term, so A of 4 is 12, and then they give you R. So we're going to solve for our first term. It's a little bit harder, like we talked about how you would subtract that number 3 times when it's arithmetic, because you're going from 4 to 1. It's a little bit harder because then you're having to divide by 2 every single time for 3 times. So that one is a little bit more difficult. It may be easier to just plug into the formula. So if I have A(n) equals A1 times R to the n minus 1, I know that A of 4 is 12, so 12 equals A1, my R is 2, and then n minus 1 is 4, so I would put 4 minus 1 as my exponent, which would end up being 3. So then I have 12 equals A1, 2 to the 3rd power, and 2 to the 3rd power is 8, so 12 equals A sub 1 times 8. I divide each side by 8, so A1 is 3/2. Let's leave it as a fraction, 3/2. So then the generic formula would be A(n) equals, my first term is now 3/2 that we found. My R is 2 to the n minus 1. Do not multiply out A1 and R. Like, do not ever combine these two. Leave them as they are, because when you're solving, according to PEMDAS, we're going to do 2 to the n minus 1 first, then we're going to multiply it by 3/2. So if I'm plugging in A of 7, because that's what it wants me to find up here in the directions, A of 7, I'm going to take 3/2, 2 to the 7 minus 1 power. So if you're doing this in your head, like without a calculator, you would do the 2 to the 6th power first, then you would multiply it by 3/2. But I don't ever want to see those two numbers in the front combined together, because that doesn't make sense. One has an exponent, one does not. So you leave it as your A1 and then your R is in parentheses. So when you plug that in, what do you end up getting? A of 7 is what? 96. Good. You could also take 12 and multiply it by 2 3 more times. Because if A of 4 is 12 times 2 times 2 times 2, you're going to end up getting 96. So then for part D, two terms of geometric sequence are A of 3 equals -48 and A of 6 is 307. So whenever we did the arithmetic, we treated it like it was slope. So we did the like y2 minus y1, so the answer subtracted over the ends subtracted. But since this is multiplied, I have to think, how many times does it take to get from the 3rd to the 6th power, or when n equals 3 to n equals 6? Like, how many times does it take? So like, I'm going from 3 to 4, which is 1, 4 to 5, which is 2, 5 to 6, which is 3. So if I'm going from the 3rd term to the 6th term, then I'm going to be going 3 times. So I'm going to say that R cubed equals the difference in my y values or my answers. So I need to find what the difference is between 3072 minus -48. So 3072 minus a -48. Not minus, what am I doing? Divided by, I'm sorry, divided by, because it's multiplied.
And then you divide that by 6.
So 3,072 divided by negative 48. And you end up getting negative 64. So basically, to get from 48 to 3,072, I have to multiply it by negative 64. That's how I get from one to the next. And I'm multiplying it by that r 3 times. So r cubed equals negative 64. If I want to take the cube root, the cube root of negative 64 is what? Negative 4. Good. So the number that goes in the exponent, like this 3 right here, like how did I get this r cubed? I'm taking the difference in my n. So I'm saying 6 minus 3. That's how I got this cubed. How I got this negative 64 is I took the biggest number and I divided it by the smallest number. So I took 3,072 and divided it by negative 48. That's how I got the negative 64. So my rate of change, or I'm multiplying it by negative 4 over and over and over again. So then once I have that, I need to find out what my first term is. So I'm going to choose one of the two. I'll do 3 and negative 48. I'm going to plug that into the generic formula. So a sub n equals a1 times r to the n minus 1. I have my rate, but I don't have my first term. So I need to figure out what a1 is. So I'm going to take my an, which would be negative 48, equals a1, which is what we're solving for. My rate is negative 4, and then n minus 1 would be 3 minus 1, which would be squared. 3 minus 2, 3 minus 1. So you end up getting negative 48 equals a1 times 16, and negative 48 divided by 16 is what? Negative 3. So then my answer, it wants like the final generic formula in terms of n. It would be a sub n equals, my first term is negative 3. My rate is negative 4 to the n minus 1.
Wait, so where'd you get the, for r you did negative 64 over the square root of negative 64?
I cube rooted negative 64. That's how I got the negative 4. And the reason why I cube rooted it is because I'm going from 3 to 6. So I'm multiplying by r 3 times. So it's like negative 48 times r times r times r gets me to 3,072.
Oh, okay.
Does that make sense?
Yeah.
Okay.
So why couldn't you do like 3072 divided by negative 48 divided by 653?
Because it's not the same as multiplying it by 3. It's like raising it to the third power. And then if I wanted to find a of 7, then I would just plug in 7. But I'm confident that you can do that. Okay, so for number 3, you're given the first term, and then 15 over 3 is 5. So that is your r, first term in r. Then when you plug in 8, you get 234,375. For part B, you're solving for the first term. So I'm plugging in 6 and negative 96, and then I'm just solving. So when you get 2 to the 5th power, and then is 32, divide that from negative 96, and you get a1 is negative 3. So then I plug that back into the generic formula with my a1 is negative 3, and then my r is 2, which they gave me in the problem. Then I solve for a of 8, and you should get negative 384. Part C is a little bit more difficult, so I think, how do I get from 2 to 4? 4 minus 2 is 2, so that's how I got this r squared. So this number, like subtracting your x's, that's what power you raise it to, equals. Then I take my bigger x value, which is the 4, so negative 3 divided by negative 12. The reason why I do negative 3 over negative 12 is because my a of 4 is bigger than my a of 2. Like I have to use the bigger number over the smaller number. because it's going from n equals 1, 2, 3, 4, and it's progressively getting either bigger or smaller. So if it's getting smaller, then you're going to have a fraction for your rate that's smaller than 1. If it's getting bigger, then you're going to have a number bigger than 1 as your rate. So that's kind of a way to think about it, to check yourself, to think that if you're doing the right thing or not. Because if you got 3, that wouldn't make sense because you're going from negative 12 to negative 3, which the number itself is getting smaller, or the absolute value of the number. So then I have 1/4. When you take the square root of 1/4, you could either have positive 1/2 or you could have negative 1/2. And it doesn't matter which one that you choose, because when you square it, you end up getting a positive anyway. If you use negative 1/2, you're going to end up getting the same answer as you would if you did positive 1/2. Because if you did negative 1/2, you would get a positive 24 for your answer when you solve for A1. So when you try to solve for A1, I'm going to plug in negative 12 and 2. So I'm going to use this one right here, negative 12 and 2. And then you solve for A1, you get negative 24. So that's where I plugged in negative 24 here. My rate is 1/2. You could do negative 1/2 and then a positive 24. They would be the same thing. And then raised to the n minus 1. When you plug in 8, you get negative 3 over 16. Yeah, these should be 1/2, sorry. But I don't think that changed the answer, did it? No, you have, I'm sorry, is 1/2. 1/2, not 1/4. Okay, and then the last part is the sum. That's kind of what we did at the end of the last section. You will have this formula. So the sum of a certain number, like whatever your n is going to be your first term times 1 minus r to the nth power over 1 minus r. So when you're doing these, the first thing you need to solve for is you need 3 things. You need to list out 3 things because there's 3 variables in this formula. You need A1 equals, you need R, and then you need N. So looking at this sum, how I find these things, A1 is just plugging in 1 for your I. So I can go ahead and do that really quickly. 4 times 3 to the 1 minus 1, which is 4 times 3 to the 0 power, and 3 to the 0 power is 1, so 4 times 1 gives me 4. My rate is the number that is in parentheses, so what number is that? 3. So that's my R. R equals 3. And then N is going to be the number that is at the top of your summation, so N equals 16. So now that I have all 3 of those variables, I can just plug them into that formula up here and solve. So S of 16 equals A1, which is 4, 1 minus 3 to the 16th power over 1 minus 3. So be careful when you're typing this in your calculator. Remember to use your parentheses. If you have an Inspire, it's a little bit easier. But if you don't have an Inspire, I would try to do the parentheses stuff first and then multiply it by 4. So I want you to try that in your calculator and then check and see if you get the same answer as me. It is a big number. Does your calculator give you scientific notation? Yeah. If you have an Inspire and it gives you scientific notation, if you click that answer and then hit enter, it should give you the full number.
Or if you go into settings or document settings and you go to float, whatever your desired float, it'll show you the whole thing.
I think if you choose like 9 or 7.
I just did what you said.
Okay, yeah, so if it gives you scientific notation, if you highlight that answer and then you click enter, it'll give you the full decimal or the full answer. Okay, so try number 5. So when you're doing, if you have a negative for your rate, make sure that you use parentheses. So this is going to turn into, like if you have negative 2 to the 8th power, that's going to turn into 256. So 6 times 1 minus 256 over 1 plus 2. So you want to, if you want to do it step by step, that might be easier. Because you have to do, it's PEMDAS. So PEMDAS, you have to do the exponent first, then you combine with the addition subtraction. You should get negative 510. But remember, for A1, you're just using the first term. You don't have to do any math with that.